All right, so the last two questions. Um, and we have complex, and I believe we have vectors. Yeah, so complex and vectors, the two big ones. Okay, so the complex number, well, u basically stands for 1 plus 2i. They've told us that in the question. It is given that u is a root of the equation 2x cubed minus x squared plus 4x plus k is equal to 0, where k is a constant. Showing all working and without using a calculator, find the value of k. Now, it's very simple. If u is a root, that then if you just place u everywhere where you have x, uh, the entire thing should be equal to 0. And through that, you can find the value of k. Now, they don't want us to use a calculator, so there'll be some amount of working that you'll have to ensure you don't make any silly mistakes in. That's going to be a bit of a problem. Obviously, you could use a calculator just to check yourself at the end of your working. Don't do it before though, because otherwise it just, I mean, otherwise it's just very difficult to actually force yourself to do the working, and you just lose unnecessary marks if you don't do the working. Anyhow, so let's do this. Um, in fact, I'll just skip through this particular working because it's just simple algebra. That's all it's gonna be. All right, so that was the working. Nothing much to it. The only thing to point out is you had 1 plus 2i cube here. So just to ensure that you can expand that easily, just take that as 1 plus 2i square into 1 plus 2i. And for the rest of the working, just be a little nifty with your I squares. Keep replacing I squares with -1 and you should be fine. Showing all working and without using a calculator, find the other two roots of this equation. Uh, okay, first of all, let me just copy the equation here and replace it with case 15 so I don't have to continuously keep scrolling. All right, so I've just copied the information we had above here so that we don't have to scroll. Now, one thing to take note of, so you were given, and now I'm scrolling into this, I don't know why. You were given that u was a root and it's 1 plus 2i, right? Now, understand complex roots always come in pairs. There's going to be the root, and then there's going to be the conjugate, which is also going to be the root. So that information can help you solve a lot of these questions. So voila, you already have another root. You only have one more root left because you know that a complex, if a complex number is the root of the particular um, cubic equation, then its conjugate will also be the root. Now, knowing that, we can try to figure out an expression where we multiply these two roots. Now, what do we know? We know that x minus 1 minus 2i, I mean, I'm just subtracting this, right? But think of it like this: if x is equal to 2, to write that as a factor, you used to take it on the other side, right? You used to subtract it, kind of like the same thing. So, and x minus 1 plus 2i equals to 0, obviously. So, if you multiply these two, you should get an expression which you can use for further division of the original expression. So let's try to multiply. So that will give you x squared minus x plus 2xi minus x plus 1 minus 2i minus 2xi plus 2i and then you get plus 4 because you get minus 4i squared, which is the same as writing plus 4, right? You can cancel this with this. What else? Can you cancel anything else? You can cancel this with this, leaving you with x squared minus 2x plus 5, I believe. X squared minus 2x plus 5. So basically, what this is we just multiplied two of the factors, and you should have another factor here. In order to find out what that factor is, you can do a lot of things. You can just try to you could try to multiply by just some variables and just you know look at the left hand side, look at the right hand side. A more easier thing to do is just to carry out long division and to hence find out the last factor. So you have x squared minus 2x plus 5, and you have 2x cubed minus x squared plus 4x plus 4x plus 15. Did I write it correctly? Yeah. So now obviously this should not yield a remainder, because think about it, if you divided your expression with the root, it should give 0, right? So if you divide your expression by the product of two roots, it should still give 0. But so the remainder should be 0, but the quotient would be the third root that we're missing out so far. So let's carry out a long division. We want to make this equals to, we want to make this equals to 2x cubed. To do so, we can multiply by 2x, which will give 2x cubed minus, in fact, let me write this out a little better. I think it's fine. In fact, sorry. All right. Okay, so 2x cubed minus 4x squared plus 10x, and remember the signs here, they flip because you're subtracting. So this becomes 0. It becomes minus x squared plus 4x x squared, which is basically plus 3x squared. It becomes plus 4x minus 10x. So that is minus 6x. And this comes down to join the party. Yeah. Okay. Now you have to make this equal to 3x squared, and to do so, you just have to multiply by 3 because it's already x squared. So that would make it 3x squared minus 6x plus 15. And that's 0, 0, 0. Which is good because you know the remainder is now 0. You know you've done it correctly. Which means that 2x plus 3 was the last factor. Which means that x is equal to minus 3 upon 2 was the last root that we were missing. And they wanted us to find the other two roots. So there you go. Your conjugate was one of the roots. That was one of them. And x as minus 3 upon 2 was another one of them. And that's it for this part. So let's move on to the second part. Now, on an organ diagram, sketch the locus of points representing complex numbers z. Satisfying the equation z minus u is equal to 1. Determine the, okay, and then you have to do something else. We'll look at that when we get to it. Let's just do this part first. So when we say z minus u is equal to 1, we mean that the distance, that the complex number z exists when the distance of that complex number from u is 1. So z exists when, you know, like the distance from u is 1. That's the idea. If you draw your organ diagram, here you have your imaginary axis. Here you have your, I'm not going to draw the fancy notation. This is your real axis. And now I've already copied down u just to make our lives easier, so that we don't have to scroll. Otherwise, it was already given in the question. So u is one of the real axes and 2I on the imaginary axis. So this is u. And the idea here is that z is any point that is 1 away from it. So z could be this. No, in fact, z couldn't be this. That, because that's 2 away from it. Okay. So z is any point that is 1 away from it. I mean, z could be this. Z could be this point here where this is I. Z could be this point here where this is 2. B could be this point here, where this is 3i. The idea here is B could be any of these points. So if you think about it, it's basically drawing a circle around this particular point, around point U with radius 1. So my handwriting is really bad, but I just write what I drew. Circle with center U, radius 1. I can try to draw this again. I don't think it'll get any better than this first time, though. Something along this line. These are all the possibilities of Z. Now you have to determine the least value of arg Z for points on this locus to give your answer in variance to correct to two decimal places. Okay, so the idea here is the least value of the argument would be where this the line that you draw. I mean, that's kind of like the flattest. That's the idea. Where it's the flattest, it would hence have the least argument, where your argument kind of like going to be this angle here. Okay, so now this raises a few issues. Now it would be flattest, I believe, where it is tangent to the circle. Because if you look at it here, let me just explain it better. In fact, let me just explain this on a separate slide altogether. All right, so I've just copied the sketch onto a fresh slide. So I can explain this. Now, your argument is obviously going to be, it's going to be a line that extends from the origin, and it's going to be the angle it forms with the positive x-axis, something along this line. Like whatever line this is going to be your argument. So that's fine. But the idea is, where would the argument be smallest, I believe, or the least value? So, and it would be so where the line just touches the circle. And the reason for that is, if you think of it like this, um, in fact, I believe the circle needs a little work. The circle would in fact be something of this sort. It has to touch. Yeah, and basically it touches the x because the radius is 1. I know it doesn't look like a very nice circle, but like, just bear with me for a second. Anyhow, so let's draw this again here, and let's think where your argument is going to be the least. It's going to be the least where your line is flattest, because obviously this line would have a greater angle than, let's say, this line, or this line would have a greater angle. Line X would have a greater angle than line Y. Line Z, however, would have the greatest angle, the greatest argument. You're looking for the flattest line possible. And obviously, the flattest line possible is where it doesn't intersect the curve, it doesn't intersect the circle, but it just touches and goes by. It can't be any line flatter than that. Otherwise, it's not even an argument of Z. That's the issue. So it just has to just touch. It just has to be tangent to it. Something along the lines of like, yeah, okay, very bad line, but you get my point. Now, if something is tangent to a circle, we know at this particular point, we're not too sure what this particular point is, but when it comes down to the real axis, it will form a 90-degree angle. However, we have no clue about any of the sides of this, and we have to find this, which is theta, that is going to be your argument. But what we can do is we connect this with the what? With the center. We know the center, this from the center to the circumference where a line is tangent to it, it makes a 90-degree angle because it's tangent to it. So wherever the line is tangent to a particular point, if you draw a line to the center of the circle, it will make a 90-degree angle. And you can join this line like so. What do we know about this? We don't know that much either, but we know that this is 1 because that is the radius. Okay, but we can do another thing here. And what color? Let's use green. What if we connected this? This would obviously also be 90 degrees. This is 1 because that's radius, but we know another thing about this particular triangle. We know that this is 2 because that's 2i, right? So since we know this is 1, this is 2. We can calculate this particular theta. Let's call this angle alpha. This is opposite. What the opposite is being used and the adjacent is being used. So let's say tan alpha is opposite was 1, adjacent was 2, which makes alpha is equals to, um, I believe we have to give our values in radians, so that's what I'll stick with for the entirety of this question. So tan inverse half, um, tan inverse 1 upon 2. Well, it's not giving you any nice values, but you're getting 0.4 6 4. How does that help you? Well, it does because it can help you find theta. However, for it to help you find theta, you would need to know this particular angle. If so, then you could add these two angles. If this is alpha, and let's say this angle was just for phi, for example. If you can find alpha and phi, we can subtract that from 90 degrees, and you get theta. So we don't have phi, and the reason we don't have phi is because we only know one side of the triangle here, but you can find this side as well. How can you find it? Because it's the hypotenuse of the triangle in the green. And you can find the hypotenuse of the triangle in the green. It will simply be x squared. In fact, let's do simply. It will simply be root 2 square plus 1 square, which is root 5, I believe. Let's take it to be x. Right, 2 square 4, that's on root 5. So now you know that this side is root 5. Now you can do a few things. Now you can find out phi. Phi is using the opposite and the hypotenuse. So that is going to be sine phi is sine phi is what's the opposite is 1 and what's the hypotenuse is root 5. So now you can calculate sine phi, or you can write sine inverse 1 divided by root 5, which is incidentally also 0.464. Now to calculate theta, which is your argument, you just simply make 90 minus, well, both of these were the same. So just change this to 0.464. So you just take this into 2. I'm sorry, this obviously won't be 90. We're doing it in radians. This will be pi upon 2. My apologies. So pi divided by 2 minus answer, and that should be giving you 0.6435. Oh, to what level of accuracy? They want to do 2 decimal places. So I can simply round this off to 0.64 radians, and you have your answer for the least value of the argument of x. All right, last question, vectors. We can do this. You have the equation of a line L, and if let's just write it down in a more simpler form. So the line passes through the point 4, 3, and minus 1. I just hate the IJK notation. I just can't stand it. So I just rewrite everything in a form I find to be simple. Yeah. And you have the plane as well, and it wants you to find the position vector of the point of intersection of L and P. A very cliche question. So you first find R in terms of lambda, so that will be 4 plus, well, not lambda, mu in this case, 3 plus 2 mu minus 1 minus 2 mu, sorry, right? And the idea here is you can think of R as to being certain values of x, y, and z, right? Now the idea here is that for the point of intersection, the values of x, y, and z in the plane and the values of x, y, and z in the line should be the same. And hence you can simply equate these values of x, y, and z. You can put them inside the equation of the plane. Let's do that. That'll be 2, and what is the value of x? Value of x is right here, 4 plus mu. minus 3 ys3 plus 2 mu minus z, no, not minus z. You have to write the value of minus z is equals to 4. Let me quickly do the simplification to get your value of mu. All right, and some simplification can simply give you mu to be minus 2. Now be careful, don't stop here. You haven't gotten your answer. You have to find out the values of x, y, and z. You go ahead and you put this into your equation of the line that you had in terms of mu. So you have to do that. So that'll be 4 minus 2, 3 minus 4 minus 1 plus 4, which gives you which gives you points, basically gives you the points of x, y, and z, which are 2 minus 1 plus 3. Kind of gives you coordinates, but you can also call coordinates to be position vectors. So basically this is going to be your final answer. So 2 minus 1 and plus 3. Part 2, find the acute angle between L and P. Now, let's say we have plane P here, and let's say we have the line L passing through this. Now, it's difficult to find out the acute angle directly, but what we can do, if this is the normal of plane P, so the normal and the direction vector of the line, we can do scalar product on them to find the angle between them, and then we can just subtract that by 90 to find the angle between uh, the direction vector, which is basically the line, and the plane. Again, all of this would depend upon the actual angle between the normal and the direction vector to ensure that we find the acute angle. We're going to have to be a little careful here. You can simply find out the normal. You can read it off by the coefficients of x, y, and z. So that normal is 2, minus 3, and minus 1. So the normal is 2 minus 3 minus 1. Just look at the coefficients of x, y, and z. And the direction vector you can pick off simply by looking at this. This is your direction vector. Again, with scalar product, you're going to be looking at, using the normal and the direction rather than the normal and the entire vector equation of the line. The direction of the line is more than enough. And in fact, that's what you will be using. So the direction vector, what was it? 1, 2, and minus 2. So 1, 2, minus 2. Okay, so you use scalar product. You do 2 minus 3 minus 1 product 1, 2 minus 2 is equals to 2 square plus 3 square plus 1 square, which is basically like the magnitude of the normal into 1 square plus 2 square plus 2 square uh, into cos theta. You simplify this. So this is 2 minus 6 plus 2, right? And what are you getting here? 2 square plus 3 square plus 1. You're getting 14 for this. And you're getting 9. So you'll get 3 root 14 cos theta. And you have 2 plus 2 minus 6, that's minus 2. So you have minus 2 upon 3 root 14 cos theta. You take the inverse, you find theta, and now because it's minus, it will probably be coming into a value that is greater than, let's say, 90 degrees. Do they want this in degrees? Do they want this in radians? Well, they haven't specified, which is why I'll just go ahead with my calculator in degrees, because I find degrees a little easier to work with. They won't be more. They won't be done for a longer time. Basically, more people are used to that type of stuff. Okay, minus 2, 3 root 14. So if I take cos inverse here, I'll be getting 100.3 degrees, which is obviously, even before I do my 90 minus answer, uh, this is just, it's not acute, right? So here I'll have to subtract this by 180, um, and that should give me 14. Okay, yeah. Okay, I can't believe it took me that long to subtract by 180. But yeah, but the actual answer for the acute angle would be 180 minus 100.3 degrees, which will give you 79.7 degrees. This is your acute angle. Another way to look at this is just you just take this to be modulus. So whatever value you get here, just take the positive value. If you take the positive value, you'll always get the acute value of theta. However, your answer is doesn't finish here. If you remember, as we did above, you actually calculated this, which is the angle between the normal and the direction vector. You need to calculate, let's call this phi, this. And phi would simply be 90 take away um, whatever you had calculated. So 90 minus answer is 10.3 degrees. That is your final answer. And you're done with for 3. You have a second plane Q, which is parallel to L, perpendicular to P. What was P? The plane P. Okay, so it's perpendicular to the plane P, and contains the point with the position vector 4 minus k. You have to find the equation of Q, giving it like this. Okay, so what you really need, what do you need for the equation of a plane? If you remember, it's r dot n is equal to a dot. So r is just random values. It's like x, y, z, whatever values on you want on the particular plane. So that's fine. That's going to be your x, y, z. You need your normal and you need a point. That's a. You already have a. You have a point. So you just need to figure out your normal. Now a bit of visualization is important here. Let's say that this is plane Q. This is Q. Now it's saying it's parallel to L, which means that, which you can say that the direction vector of L kind of like lies on the plane or is parallel to it. It doesn't really matter. I'm just talking about the direction here. I'm talking about the direction vector of line L. Another thing that they said was that this is perpendicular to Q. This is plane Q. Let's say it's perpendicular to Q. If it's perpendicular to Q, I can also say that the normal of Q is parallel. Uh, Wait, I think I'm mixing it up. It's perpendicular to P, and hence I can say the normal of P is parallel to Q. In a way, I can kind of say that if this is Q, if this is plane Q, then the direction vector of L is either lies on the plane or is parallel to the plane. And I can also say that somewhere, let's say here, the normal of plane P also lies on plane Q or is parallel to plane Q. Because if plane P is perpendicular to plane Q, then the normal of plane P, which is perpendicular to plane P, should be parallel to plane Q. Now, if we figure out the cross product of these two, you should get the normal of plane Q, because obviously if these two are parallel and you get the cross product, you get the perpendicular vector from these two lines. And if these two are parallel to Q, then the perpendicular vector from these two should also be perpendicular to Q, which is going to be the normal vector. If you get the normal, then the question is over. You're all good. How do you calculate the normal? Now there are many ways to do it. This is the way that I prefer. So you take plus I minus j plus k. You're just going to have to remember that sequence, I'm afraid. Plus minus plus, basically. Uh, and you write down the values of first the direction, whatever value you want to write of first, that doesn't matter. But let's look at the direction vector of L. The direction vector of L was 1, 2, minus 2. You write 1, 2 minus 2. And what was the normal of the plane P? The normal was 2 minus 3 minus 1. 2 minus 3 minus 1. Right? 2 minus 3 minus 1. 1, 2 minus 3. Right. Okay, so the way I look at this, the way to get your values, your normal vector for the plane Q is you first, if you want to calculate the value for I, you're going to look at the values that are not those of I. So you're going to look at the values from J and K. And you're going to do something very similar to what you used to do to calculate your determinant in matrices. So it's going to be, uh, it's kind of going to be these two multiplied and subtracted by these two. That's kind of going to be the idea to calculate the value for I. So it's going to be minus 2 minus plus 6. Uh, and then for j, you just look at the other two values. So then it's going to be minus 1 minus minus 4. Except with j, remember with j, you're calculating minus j here. So you're going to have to multiply the overall thing with a minus 1. Okay. So then for k, you just look at the two columns that aren't respective to k. So you look at these two. That's minus 3 minus 4, which should give you um, what should give you minus 8. This is minus 1 plus 4, which is plus 3, but it is a minus 1 here with j that only happens with j, so that's minus 3. And this is minus 7. And this is your normal. You got your normal vector. Okay, so this is the last step remaining. If you remember, the vector equation of the line of the plane was r dot n is equals to a dot n. So r is just x, y, z. Dot n is minus 8, minus 3, minus 7. You could just write this as 837 because that would just mean looking at it in a different direction, which is completely fine. It could be perpendicular to the plane, like out of the plane or into the plane. It's the same thing. But even if you don't do that, even if you just continue with minus 8, minus 3, minus 7 instead of just simplifying this to 837, it will still give you the correct value because then you can cancel it out on both sides because it's being multiplied on both sides. What is A? A was it's 0i. It is 4j minus 1k. So it's 4 minus 1. Minus 8 minus 3 minus 7. This is minus 8x minus 3y minus 7z is equals to 0 minus 12 plus 7. This is minus 8x minus 3y minus 7z is equals to, I believe, minus 5. And you can just take minus to be common. And there you go. Thanks for watching. On the side note, something I noticed in my stats paper as well. I think from 2018 onwards, I don't remember seeing this stuff in 2017, but 2018 onwards, they've given you an additional lined page, which is very nice because I mean, obviously you have a lot of crossing out that you do on the day of the paper, so it's nice to have an additional page. It's nice to know that you have an additional page, which hopefully this video has also done. Anyhow, that's it from my end.